Okay, so from the information about the vertical or the change in elevation of the structural contours, we start at the fault at 700 here. So we go from 700 to 800, that's 100 meters, 200 meters, 300 meters, 400 meters. So our vertical offset is 400 meters. And you can use your ruler, your scale that you make here. And doing that, you'll see that the horizontal distance, the change in horizontal distance is approximately 800 meters. So you're going along 800 meters in horizontal distance and with a vertical displacement of 400 meters. And so if you remember the calculation, so tan minus 1, 4 over 8 in this case, and that gives you a dip of the fault around 26 degrees, 26.56 degrees. Okay, so you've answered the first one, the dip of the fault plane. That's 26 degrees. So the other question is which way is the fault dipping, and you can tell that from your structural contours that it's dipping to the southeast, hopefully. All right, so you can see that it's higher up here and lower here, and the strike is northeast, southwest, so the fault is dipping to the southeast. If we were to draw a strike and dip symbol, it would be something like that. Okay, so that's the strike and dip of the fault. Now you can use all of this information to make a cross section, and I recommend when you're doing all of this, in fact it's probably best, unlike I've done, and you can see I've made a mistake up here, I started in pen. It's probably best to start in pencil in a light sense, and then if you make a mistake you can rub it out, and when you hand in your final one, go over in pen and then perhaps colour in the different units so it's easy to see exactly what's going on. So if we want to draw a cross section, I recommend the best place to draw a cross section is perpendicular to the strike of your units. And of course if you've got a fault that's striking in a different way to the units, you might want to draw several cross sections to encompass both the fault and the units. That's something you have to decide. But in this case we can draw one cross section, and so I'm going to draw it straight through the middle, and we're going to draw it perpendicular to the strike of the units and the fault. So I'm going to draw it across here, and let's say this is X and this is Y. Okay, X and Y, that's going to be our cross section. And then we can put all of that information onto our ruler that we make here. So we can just use a scrap piece of paper and put all of that information onto the paper along our cross section. So if we have this as X and this as Y, they're the extent of the map, and then we can fill in all of the points that our structural contours cross our cross section. So that's A10, that's A9 and B10, that's A8 and B9, that's B8, F11, F10, F9, F8, F7, A8 and B9, A7 and B8. So that's, as far at the moment, that's all the information we need. There's also some unconformities under here, right? So that one there is also U11. That's nothing, and that one there is also U10. Okay, so already you can see that there's going to be a different dip between the units below the unconformity, A9, A8, B10, B9, etc. Those contacts, and there is at the unconformity. So something has changed. There's a different amount of dip because these ones go over twice the lateral distance or the horizontal as the units below the unconformity. So again, there's more information that you can get there. So then we can take that information and we can put it onto a cross section, a profile. So here's one I've made using the scale that's given. I've plotted the elevation. In this case, I've put it to the squares on this grid paper to make it convenient. It's approximately accurate. So if you did that, that'd be fine.